Smith made a comment. Can you make a series on the tabs in EV3 and what to do with each block? So today is my 5th video in the series, and it is the dark blue tab or the advanced tab. This tab is named advanced because there's some stuff in here. This is what I like to call the miscellaneous tab, where they didn't really know where else to put it, so they just kind of threw it all here and called it miscellaneous. Don't know why. So the first block is the file access block. And so this lets us read and write to files on our brick. So we could say write to the file ABC and add to the end of it hi. So now if it doesn't have the file named ABC, it'll create a new one and put hi at the front. And then we can read from, and we specify the file name again, and this gives us everything in the file. So right now that would be hi, unless there was something else. But the problem is, if we run this, and then we run it again, the file will say hi, hi. It won't just say hi. So we either have to delete the file ABC. Yeah, we have to delete the file ABC if we want to make sure it only has what we want in it. So we could do something like write this in a different program, and then in this, delete the file and write it in a different program, and then read it next program over. Because the file will stay between programs. It won't stay between projects because it saves in its project. So all the different things the file access block can do is you can read from a file with the name you specify up here. You can wire it, or you can just type it in. You can read text or numeric. If you know it's only numbers, you can just read numbers. You can write to it just by putting text in. Again, file name wired, or type it in. You can delete it. Again, file name wired, or type it in. And you can close a file. What closing a file will do is when you close it, next time you go to read from it, you'll read from the beginning. You won't read from the... No, next time you go to write it, you'll write at the beginning. You won't write it at where you just were in the file. Okay, the next block along is the data logging block. So this block lets you get data, but in order to view it, you have to bring it back in, plug it in, and import it to your computer. So it's a little bit of a pain, but if you need to be able to see how your gyro angles rate, which is what the default thing is, during a certain turn is changing, and you want to see that in a graph, you can use this. So what you do is you specify the name that you want it to create the data in, and this is for the on. I'll go over what the other ones are in just a bit. But so for on, you specify the rate, and this rate, they don't have a unit because this next one specifies the unit. 0 is samples per second. So if we choose 0, then every tenth of a second, it would choose a sample, because it would try to take a sample it would try to sample 10 times in 1 second. And then this bit is seconds between samples. So in this case, it would take a sample, wait 10 seconds, take a sample. So generally, you're going to see this more. And so this is every tenth of a second, take a bit and add it to the graph. So you can specify the port of the sensor you want, what sensor you want, and what you want it to be measuring, and you can add up to 8 sensors. Giving this the record for the longest block. You can't even make a my block that can be longer than this. So that's just a silly little record, but the data logging block can be the longest one. And you can choose all sorts of different things. So I'm just, a note here though, this block, if you're using the retail version, it's not going to be there. This block is only for the education version, and I'm going to get rid of it so it's not so ridiculously long. This block is only in the education edition. See, mine's LEGO Mindstorms Education. You can now download this for free online. I'll put the link in the description. And if you want to be able to do data logging. Another benefit of using the education is it automatically comes with all of the sensors imported, and you don't have to download the blocks individually. So the other bits, the other choices for data logging is on for time, and you can choose seconds or minutes, and you choose how many samples a second and that kind of stuff as you did before, but you also choose how long it lasts. The other one is single measurement, so it just takes one measurement and puts it in an unreadable file format rather than just reading the thing once and sticking it in a file. I'm not sure why you would prefer this over doing something that looks I'm not sure why you would prefer this over doing this, since they do exactly the same thing. But who knows? Maybe if you wanted to be able to compare stuff. I don't know. You also, the final choice on here is stop. So this is for when you turned it on earlier. So you said, for my data, turn it on, and then do a couple random maneuvers. Actually, those aren't really random because they're just driving straight. Who knows what that'll do. Some random amount of spin, and this will check the gyro angles, the gyro sensor's angle. And then at the end, if we want it to stop tracking the gyro sensor's angle, we just drag up another one. We say my data again, and we tell it to stop. And so this will stop it recording. The next block along is the messaging block, okay? So this block is pretty cool. What you do is you have to have Bluetooth turned on your brick, and Bluetooth turned on the brick you want to send a message to. So you specify the message title, you put it in here, and you can send text, numeric, or logic. I'm going to walk through it with text. It works exactly the same with numeric and logic. What you do is you type in the receiving, so the brick you're going to send it to's name. So if it's still default, you could type EV3. That's the default name. And that means it would send it to all the bricks that they weren't smart enough to change their brick name. If you want to see how to do that, this right here, my brick is really low battery. So right here, there's a little box that pops up, and if you click on it, you can change the name from in there. And then you can type a message. Okay, now if you were to just run this and you didn't have any code on the other brick, it wouldn't do anything. It would just receive the message and say, oh, well, a message was sent to me, but you weren't looking for a message, so interesting, but not really relevant. However, if the other robot is saying receive text and it has the same message title, then this will give them what you put in here. So this is also true if you were to do send numeric. So I could type just any number in here, 12, and then this would receive numeric, and this would output 12, which is pretty cool. And then another thing you can do on the other end is compare. So compare numeric lets us say if the message I got in ABC is less than 50, the outcome of that comes out here. Or you could just get what the message number was. You also can do this with text. This is the only way you can compare text besides with switches. And you can only say equals or not equals. So if it's equal to the text I type in here, send text. If it's equal, it'll put a check out here. If it's not, it'll put an X. And you can get just what it says if you want as well. The next block along is Bluetooth connection. You can turn it on, off, initiate, connecting to, and you give it a name to connect to, and you can tell it to clear a device that it's connected to. So that lets you, if you wanted to sync it to your computer, you could say initiate Bluetooth conversation with the name of your computer as it is searchable to Bluetooth devices, and then when you were done getting whatever you wanted from the computer, you could close off that connection. Then the next one is keep awake, and so this just tells you the time until sleep. So this lets you do things like when it's about to fall asleep, like wait until this is like a tenth of a second and then like make a noise or something. And then this raw sensor value. So what this is you choose the port you want. Port 1, port 2, port 3, port 4. And it just gives you a number. So this number hasn't been modified by any of the internal algorithms. This is just the raw sensor value. So if, let's say you had a color sensor plugged into port 1, it would give you the straight RFI, reflected light intensity. That's not RFI, RLI, sorry. It would just give you it without having applied any modifiers for, oh, well, if the ambient light is different, or, oh, well, earlier you told me that actually this was, white and this was black. No, it's just going to straight up give you what it sees. So this is also useful because you can use this if, let's say, the firmware in your sensor is old. You can just get the raw sensor value and not have compatibility issues. The next one is the unregulated motor block. So all you can do is you turn it on, you set power, and what port A, B, C, D are wired, and it goes off and does its own happy little thing, and it doesn't apply any internal algorithm to the power to make it stay constant. It just tells it go at this power and assumes it will. This is useful for if you've got a drive that you think the internal algorithm in the motors is messing it up as it's trying to correct for load and stuff. So you could just use this and verify, okay, yeah, it really is that problem, and then just use those. The next block is actually pretty useful. Invert motor. So you choose the port, and you can choose yes or no. Now what this lets you do is, let's say you have your drive motors. B and C. So, and when you built your robot, you weren't thinking about having it so that when you spun your motor with positive power, it would drive forward, and when you spun it with negative power, it would drive backwards. So your robot is built so when you spin it with positive power, it drives backwards, and when you spin it with negative power, it drives forwards. And that's always really confusing to everybody, because they're like, wait, what? Why did that just go the wrong way? So what you can do is you can have like a setup block that says invert the motor true. That means the motor's inverted. So if you wired your robot normally, like had your motors normally, where normally, without this being true, it would say positive is forward, negative is backward. Now, if we turn the invert on, then all of a sudden positive is backwards and negative forwards. Or if you put your motor in backwards, that's when it's really useful. Because then positive is forwards again and negative is backwards again. That's what that's useful for. This next one is the stop program. Now, this is interesting because when people are first going through, if they're shown this, they'll think that they have to have the start block, a couple blocks, and then an end block. Especially if they've programmed in like Java or C++ or another text-based one where you have open brackets and closed brackets to signify when you are starting and ending segments of your program. But that's not actually what this. You don't need that. The program will end just fine without it. What this does is, if in a special condition you want it to end, like in another thing right here, like you could say in a separate branch. So we've got our normal we've got our normal thing. I don't want that to be a wait, but it drives happily along for one rotation repeatedly because we're not intelligent enough to make it like 5. And so it waits for 1 second and then it drives. But in this case, we could say wait until the center brick button is bumped, and then once that happens, into the program. So if while we're driving along happily, our robot gets stuck on something, we could just hit the center button and it would end. Now, you might ask yourself, doesn't that do the exact same thing as the back button? And yes, in this case, that would be the exact same thing as the back button. But you can do things like time. If a certain number of seconds has gone by, you can do messaging. You can do sensors. And those things, like if for some reason the ultrasonic sensor reads that we've gone too far, it'll automatically end the program. That's a bit drastic because it will end every program it's in. So if you had that stop bit in a MyBlock, not only would it end the MyBlock, but it would end the program running the MyBlock. And if that program was a MyBlock, it would end the program running the MyBlock running the MyBlock, and so on and so on. It would bring you back to the base menu. So it's basically like hitting the back button. But you can specify, and you don't actually have to hit the back button. The final block here is the comment block. So there are 2 ways to make comments. With this little button right here, which pops up a little box like this, and these comments are scalable. They can fit as much as you want, and you can type of them. And I cannot type. So that's a comment, and then I could shrink it to make it fit exactly where I wanted, and then put it somewhere. But if I wanted to, but unfortunately, since this just sticks there, let's say, oh, actually, this isn't consistent enough. You know what? I'm going to add a turn in here. Well, all of a sudden, it's not commenting the right thing anymore. So that's when these things come in handy, because they're in the line of the code. So if you add another block, they slide another block down. And the only downside to them is they're not scalable. So if you type too much, I cannot spell either. Like, let's say we were to type, this is a comment with a space at the end so it doesn't look weird, over and over and over again, eventually we'd run out where we couldn't see it anymore. We'd have to access it to be able to scroll. And that's a bit of a pain. But beyond that, the comment block is cool because it's not just floating in space. It actually is on the line, and so it's not going to shift around. It's not going to shift relative to the blocks. That's all of the blocks in the blue tab. As always, if you have a video recommendation you want me to try and do, just put it in the comments, and I'll be happy to make it.